what happens when we accumulate instantaneous changes over an interval? So that's the area under the curve. Some of you have been in physics and have done areas under curve, and you know about integrals. We'll get to those. Right now, we're going to do strictly geometry. There's absolutely no calculus in this lesson whatsoever. So we're going to look at the distance you travel. We're going to do a rectangular approximation method. This author calls it RAM. I don't care for it, but it works, I guess. And we may do volume of a sphere. We're not going to do cardiac output. I could just cross that out. Okay. So, distance traveled. Consider a train traveling at a continuous rate of 75 miles per hour for 3 hours. What is the distance traveled? Well, the distance you travel is the area under the curve, except there is no curve. I guess we'll just do this. Whoops. Sorry. So I'll just draw another picture. So here's your time, and here's your velocity, and you're going to travel at 75 miles per hour the whole time. And so this is t equal to 3. And so remember that distance, remember this from 9th grade physical science, is what? Rate times time. Do you remember that? I taught 9th grade physical science a long time ago. For one semester, but I remember teaching that. Distance equals your speed times the time. And you can do it dimensionally. It's just the area under the curve. It's just the area of that rectangle. So this is 3, this was 75, and let's put the dimensions in so we can see the dimensional analysis. So the distance you travel is equal to 75 miles per hour. So in 1 hour you will drive 75, this is a train, isn't it? Times the number of hours, which is 3 hours. And you see how the units work? That the units would cancel out, and I'm left with miles. Now, on the AP exam, you can leave it 75 times 3. You don't have to multiply it out. And if you multiply it out wrong, you lose the point. And by the way, some people did that on their final. I took the point away. You don't ever ask you to simplify. So I would leave it. Just leave it 75 times 3. And but we sat at the tables grading, and I remember we were all sitting there going, why don't they just leave the answer? Because if you do it wrong, you got to take the point back. Just so comparatively. But that's okay, because what are they trying to assess? They're trying to assess what you know regarding calculus, not regarding arithmetic. Now, sometimes when you're on the multiple choice, you're going to have to figure that out. Now, that was pretty easy because the velocity was constant. So I could just use geometry. It's based on height. It's a rectangle. What if it's not constant? What if its velocity is t squared? And we're going to say t greater than or equal to 0, and I want to figure out where I am at t equals 3. And where did we start? Oh, we started at 0. I forgot to answer this question in last class. So let's graph the velocity graph. Wait, let me make that bigger. And so here it is. It's t squared. This is t. And here's 3. And we know where this is. Where's that? It's t squared. So it's a 9, right? And we're going to use our calculator, too. I'm going to show you something really cool about that. So what I want to know is you started at the origin, and you travel a certain distance. Where are you going to be 3 hours or minutes later, depending on what it is? Well, it's just the area under the curve. That's all. And it says we are going to divide this into 3 rectangles of equal width. So let's do that. So, and I'm going to do my best. What I do is then draw the rectangle, just the vertical piece of it. And then we're going to figure out what the rectangles are going to look like. We will find the y value at the midpoint for each rectangle. So you could put rectangles underneath the curve, like this. Let's see, it's on the left side. If I have it hit on the left side, that's not under, that's over. That's what they call the left rectangular approximation method. That was called. And if I did this one, I took the height of my rectangle being I'm backwards. The right one. Being on the right side, This would be an overestimate. Now I'm going to undo all that. Because that's the plan. I'm going to do a whole bunch of these. Don't worry. Here we go. You could also do what I was starting to do, the left one. Let's do that one. And then we're going to erase that one too. And that means I'm going to use the left endpoint for the height of my rectangle. That's 0, so there is no rectangle. So I'm going to take this for the height of my rectangle. Then I'm going to go to 2, and I'm going to take that height to be the height of my rectangle, which is clearly less than the curve. A lot less, it looks like. Well, the best approximation is the midpoint. I'm going to get this out of there too. And what I do to do the midpoint rule, and that's the one I see most often on the exam, but not always. You take your interval and you go to the midpoint. So where am I going to be on the midpoint here? It goes from 0 to 1. Where's the midpoint? A half. I'm going to use fractions, but I have reasons for my madness. And then I'm going to go up to the curve, and that's the height of my rectangle. So the right part of it is below the curve, and the left side above the curve. You know what? They actually balance out pretty well. So where am I going to go to get halfway between 1 and 2? 1 1/2, or 3/2. So to get the height of my rectangle, I'll go up to the curve, and then I'll just go over here. So that part's underneath, but this part is above. So we're going to use rectangles that are using the midpoint to find the height. So where am I going to go here? 1/2, 3/2, what do you think the next one is? 5/2. What's the next one after that? 7/2. Okay, look at the pattern. So we're going to go up here. This is the midpoint. I'm going to find the height of the function at the midpoint, and that'll be the height of my rectangle. Well, that's not too bad. Some is over, some is under. That doesn't look too bad. It looks like it's going to balance out a lot. And so how do you do this? You take area is equal to base times height. So there's only geometry here. It's area of a rectangle, and I just taught that in geometry. And this is ours today. It's just base and height. So how big is the base? 1. So the area is equal to 1. And the height is the value of the function at that midpoint. So it's times f of 1/2. You've got to be a good bookkeeper. You'll get lost in your own work. Plus. Then this base, which is 1. And how do I find that height? It's f of 3/2. Plus 1, and then it's f of 5/2. And then we also started the homework a little bit too. And what was f of x? Actually, it's v of t. V of t, and my function is equal to t squared. So why did I not go to decimals? Because it's 2 hard to square. Actually, I don't have a problem with it, but fractions actually are easier. So what's f of 1/2? It's 1/2 squared. Plus, then it's 3/2 squared. Plus 1 times 5/2 squared. It's not particularly difficult. It is tedious. Testing. Because it said we wanted to use the midpoint. So if my endpoint is 0 and the other endpoint's 1, I want halfway. Halfway is 1/2. And how do I get the height? It's the value of the function at each of those midpoints. So we'll set up a couple problems to do out of your homework. That's 2.5. That's the midpoint. It's just easier to square because it's easy, right? What's 1/2 squared? 1/4. It was nice that the bases were all 1. That was really nice. Plus 3/2 squared is 9/4. Plus 5/2 squared is 25/4. And then what do you do to add fractions? Just add them up. 1 and 9 is 10, and 25 is. Don't add those denominators. Which is approximately, well, it is, not approximately, it is 8. That goes in 32 times, and 3/4. or 8.75. Okay, that's pretty cool. The calculator can do this too. Notice I'm just adding rectangles. And I do have some really nice programs for you that all you do is you tell what the function is and you tell it how many rectangles. If you want to get on the left side, right side, or midpoint, or extrapolate. That's the base. Remember? There is based on type. I chose the base of all to be 1. In the homework, they don't tell you how many rectangles. Make your life easy. Don't make it hard. There will be no more than 4, maybe 6 rectangles at most on the exam. Probably 3. When you do this, it will be on the exam. And this will have a name. It's going to be called the Riemann sum. And that always freaks you out, but that's just the name of the guy. It was, I don't even know the first name, but his last name was Riemann. So he's the one who got credit for doing these. Because what I can do now is estimate the area underneath that parabola. It's not exact. And I always tell my students, I said, just change the name to Golembeski, because that's all it is a name. Name of the guy. You guys freak out when you hear it. We'll just say, oh, that's a Golembeski sum. And you will see. They'll say, find the Riemann sum. You will see that. What do you think would happen if I put in more rectangles? Would it get better? What do you think? If I divided this into even more rectangles, what if I did this? And I don't care if I do midpoint or not. Don't you think my results would get a little bit better? I'm supposed to try and find one of each. 2 in here. Yeah, the more I put in there, the better my approximation is going to be. Well, let's look at it on the calculator, because it's kind of cool. If I can find it. So I already have mine set to go. We knew the window was from 0 to 3. So if you want to do it with me, I'll slow down. Because you're going to learn a new feature of your calculator you didn't know. So I put y equals x squared. That's what's in there. My window, 0 to 3. And then because, and I have a table, you can see that. Oh, the table size isn't right. But when x is 3, what's the y value? 9. So I want it to 10. And so then I press graph. Are we ready? Then there it is. In fact, I could turn it off and make sure it... Whoops. We'll just rekey that. So there he comes with the graph. And I can find the area under the curve from 0 to 3 because there's a button on the calculator that will do it. What the calculator is doing is just dividing it to tiny, tiny rectangles and adding them up. It doesn't know calculus. So we go second, and we go to calculate. And this little symbol here, that f of x dx with the differential, that's what we want. Oops, can't do that. What kind of calculator? And then it says, where do you want to look at the area? We want to look at the area starting at 0. If you didn't know, you do now, that you can just type in the numbers for your limits. You don't have to arrow over there. I never do it right. And I want it to be exact besides. And there it is. Now, my program with the Riemann sums actually divides it up, and you can see the little rectangles. You can put in 20 rectangles if you want. This is probably, I don't know, I would guess maybe it's 100 rectangles in that little region. Maybe it's more than that. But it does look pretty solid. And the symbol is this. And then you have f of x. And you have to have that differential, because you know really what that is? That's the base. I don't like my tears. That's the length of the base. It's delta x. And the height of my function is f of x. And s, this little s thing, means sum them up. Sum the areas. That's all you're doing. Okay. Now you have 3 different methods you can use. You can use rectangles that hit on the left side in the interval, or the right side, or the midpoint. I'm going to destroy this. I'm going to tell you that right now. Okay. So let's go ahead and draw those. Now, when I do the problems, divide the area into the number of rectangles that will give you nice numbers. So when you look at the problems, they said it goes from 0 to 3. Let's just do 3 rectangles. I suppose you could do 6, but then it gets It'd be busy work. So I'm going to draw a picture. This is the plan. What did I do? Oh, I'm learning things I don't know. Okay, we'll just do the old-fashioned way. Draw it. So I'm going to show you what happens when you have the different rectangles. Hi. See who's in here. What did you say? Yes. We'll find out. It'll be perfect. Okay. We're going to make this nice. Then we'll do... Now, you may think it's concavity that makes you a decision here. Let's take these and let's do a left endpoint here, an LRAM. Okay? I'll do 4 rectangles. Yeah, I'll do 4. I'm just going to show you what happens. You think it's the concavity that makes it an overestimate or underestimate, but it actually isn't. It's increasing, decreasing. I know I'm tempted to do the same thing. So what I'm going to do is get rectangles. I'll find the height by using the left endpoint of my base. So here's my base. Right there. And so my height is the height there. Guess what that is? 0. And then I'm going to do the next one. So here's my base, and I'm going to find the height of the rectangle using the left endpoint of that base. That's this. There it goes. And I'm going to come over here and do the same thing. I'm going to look at my base, I'm going to go to the left side and go up and use that Y value. And what do you think? I'm going to go to the left side and use that. Overestimate or underestimate? Yeah, it's an underestimate, isn't it? Well, I never remember, so I just draw little pictures. That usually tells me. Let's do the right one. The midpoint's always between them. So I'm going to do the same thing. I'm going to divide it into 4 regions here. And now I'm going to have my rectangles hit on the right side. So I've traced out my base. To find the height of this rectangle, I'm going to go to the right endpoint of my segment and go up to that Y value. And what happens to that one? It's over. So go to the right endpoint and over. You see how to draw these now? Whoopsie. So I'm going to draw a new one, but let's make it decrease. And see what happens there. And there are other, I mean, you can have other ones that are increasing, but they're concave down. You can try them. And this is going to be concave down, but decreasing. And I can do them all, but I can let you try them, because once you start getting the habit of it, the hang of it, it's okay. And so I'm going to do 4 of these as well, I think. And this was this the left one, I think? Keeping mine lined up would be nice. Yeah, that's the left one. So I'm going to do a left rectangular method. So I'm going to go over here. Here's my base. I'm going to go to the left side, up, and there's my rectangle. Guess what? That's now an overestimate. So I'm going to go over here, go up to the left side, and here's the left side, and here's the left side. So you might have thought the concavity has something to do with it, but it doesn't. They're both concave up. So So the increasing, it was under, the decreasing, it's over. But, you know, I never memorized that. I just draw the picture. You go crazy if you try to do that. Let's do this one. And this is going to be the left one, right? No, wait. Can I do the left one? You'll do the right one. So, I'll divide this into 4. It's going to be on the right side of my rectangle. So I'm going to go over to the right side, go up to the function, and that's my rectangle. Go over here, go to the right side, up to the function, and across. And what about this one? That's going to be under or over? Under. Okay? That's all you have to do. So if you want to look at some of the homework problems, they're not that bad. If you're just going to use geometry. We'll do that one tomorrow, because I didn't do that in the class. That's problem 11. But we did 2. Number 2. Yeah, ask. Because you're using the other end of the end of the base. Depends on which side you use. It depends on the method. Midpoint would be the best. It'll be right in the middle. So the midpoint here would be going, here's your interval, go to the midpoint, and that's the height of your rectangle. So some is under and some is over. Whoopsie. Hold it off. Right. A little bit over, a little bit under. Midpoint's the best. We're going to put trapezoids under these too. Okay? You just draw them, you'll be okay, but it depends on which, if it's left or right. Okay. No. Okay, so let's look at number 2. I can get this to work. And 2 asks you for the distance you travel. Is it in 3 hours? I think it is. Find your distance you travel in 3 hours. So I'm going to graph it, because I know that the distance is the area under the curve of the velocity curve. So when I graph this thing, you can break this up into parts if you like. It doesn't really matter. 2t plus 1 is a straight line, and it's going to go like this. What else did I should go there? What shape is that? Yeah, I heard it. It looks like this. It bothers you because it's on its side. Whoops. Oh, no. Oh, it's okay. We'll just rotate the whole thing. You see? Now, do you see trapezoid? So it's on its side. And so I just have to find the area of this. Now, you can remember the formula, which you will have to know, but you could divide this into a rectangle and triangles. It's fine. But you have the trapezoidal rule on the exam. And the trapezoid formula is this. Does anybody remember it? It's 1/2 the sum of the bases. And when we do the trapezoid formula, I'll show you why it is what it is, times the height. So you can find this. What are the bases? The bases are the two sides that are parallel. So these are parallel. How tall is that base? That's 1. And how tall is the other base? We did 3 hours, so it would be 7. I'm assuming, I don't know what the number was. Maybe it was 4 hours. I don't remember. And then how big is the height then? This is the height. I know it sounds weird. You think that's the height, but not in the picture. It's 3, which is equal to 3. So it would be 1/2 the sum of the bases, which were 1 plus 7, times 3. I think my numbers are wrong, but I don't know. And you can leave it like that. I don't care if you multiply it out. Who cares? If you do it wrong, it's wrong. And let's see, number 3 is y equals x squared plus 1, correct? Guys, you can help me out a little bit. And this is a what? Graph of what? It's a parabola, and what are we going to do with our parabola? Lift it up more. And so now, I don't know what the interval is, though. Anybody have the book open? This is homework problem 3. Yeah, what else? That's for what? The area from where to where? The distance? It's just geometry. Yeah, a lot of words. T squared plus 1, x squared plus what? Same thing. Approximate the area under the curve using 4 rectangles of equal width and heights using midpoints. Oh, I like midpoints. Was this 4? I think it was. It's just areas of rectangles. That's all it is. We're going to use midpoints, which then, of course, will be a little trickier. So you take your base, which goes from 0 to 1, and then you find the midpoint, which is at a half, and find the height of your rectangle. It's f of 1/2. What about the next one? What's halfway between 1 and 2? Well, 1.5, which is 3 halves, and the height of this rectangle is the value of the function at 3 halves. And then the next one, between 2 and 3. Where's that one? 2.5 is 5 halves, right? So that's f of 5 halves. I didn't say it's fun. It's not necessarily fun. There's got to be a better way. There is. And that's going to give you 7 halves. So it's f of 7 halves. Oh, we have to get through this one first. Because it's on the exam. And you will be asked to do Riemann sums of things like this. Well, it's not hard. It's area of the rectangles. Base times height. It's geometry. Just base times height. Don't make it hard. I'll let you try that. And they told you that, how many there are. But don't do too many. Like I said, on the exam, they won't do more than about 3, maybe 4. Sometimes they've done them as much as 6 or 7, but that's not that common.